Okay, so in this video, real briefly, I'm going to answer the question, what is a parabola? And I know you already know, a parabola is formed, it's the curve formed by a quadratic function, parent function being y equals x squared. But of course, we have all kinds of transformations to that. So let's talk about it just in the sense of geometry. In other words, just using really distances, right? So say we've got a Cartesian plane and we've got a parabola here, right? And now, normally, what we would do is define it, using an input-output table, a T-chart. It can also be defined a different kind of way, using what we would call a focus and a directrix. So a focus is a point, and a directrix is a line that's always going to be perpendicular with your axis of symmetry, right? So, for example, this parabola has a vertical axis of symmetry, and perpendicular just means, they would intersect at a 90-degree angle. Okay, so now that that's out of the way, the whole point to this is simply that, say I had a point here on this curve, and the distance, excuse me, the distance from this focus to this point on this parabolic curve was equal to, I don't know, let's just call it d1 for distance. Well, the distance from this same point on the curve straight down to the directrix would also be that same distance, right? So these two orange lines would be equal in length. And I know it doesn't look like it on my crappy picture, but if I was able to draw it accurately, these two orange lines would be precisely direct. Even with my eyeballing it, it still looks pretty close. Okay, so you've got like a fancy word wall here. And I mean, you can kind of sum this up. So if we're talking about just geometry, it's a set of points where all of which are equidistant from their directrices and foci, right? And then we'll focus is singular for that, directrix singular for directrices, right? So that's how we would define a parabola in geometry. Okay, so then we move on to the next part of this. So all this talk about directrices and foci, it's like, well, how would we even find where they are? And it's a simple set of formulas that you can follow, right? So if we assume that the axis of symmetry is vertical, well, we have this set of principles here to follow, right? This didn't change. The vertex will always be there. The focus, however, is always going to be slightly up from, I guess I shouldn't have erased everything from my picture that I drew. Let's see if I can undo. Is it going to go back that far? Nice. Okay, so my focus, you can see, is always going to be some distance away from the vertex, right? So that point right there is my vertex, and my vertex is always going to happen at h by k. And the directrix is actually that same distance away from the vertex. All right. So my focus happens, assuming that our axis of symmetry is vertical. My focus always happens slightly above, right, at y equals k plus p. It's still the same x coordinate, still that same x, but it's always slightly above. And we see that here in this picture that I drew. And then our directrix is always slightly below. And you see these two variables here, they match. And that's because this distance right here, so the distance from here to here and here to here are both the same distance. That is this variable p here that we're talking about, right? And you'll see it over here also with the horizontal axis of symmetry, right? So that just means, instead of opening up, our parabola is instead going to open either right or left, right? So it could, depending on its a value, which we're going to talk about here in a second, open either right or left. Okay, so same basic principles here, right? Now, let's talk about some differences. Okay, so you see my side note I gave you over here. A is the same thing as 1 divided by 4p, and there's that variable p again. We're talking about this same distance, right, from here to here, from here to here. So 1 over 4p is the same thing as what we call A, which of course is our vertical stretch or shrink. So if I just kind of write this underneath the parallel. So if we're in vertex form, 1 over 4p and A, they mean they're telling us the same thing, right? Now, inversely, well, what if I want to know what P is? Well, we have that inverse relationship wherein 1 over 4A gives us P. Okay, and that's how, in the next video, we're going to actually make the calculation of where our directrix and focus is because, well, duh, we need to know what P is. We need to know how far away our focus and directrix are from our respective vertices, right? And then over here, horizontal axis of symmetry, something similar. X is equal to, we would still say A, and then Y minus K all squared plus H. Now, we're going to make some side notes about this. So this is still vertical stretch / shrink factor, right? H is still my horizontal translation, moving us right or left. Important to remember that it's counterintuitive. Okay, that of course means if I do, plus H, that makes us go to the left, minus H, that makes us go to the right. And then we have K over here, which is still our vertical translation. And that is not counterintuitive, right? That makes us go either up or down. Okay, so now let's talk about, well, what changes when we have a horizontal axis of symmetry instead, meaning our parabola opens either to the left or the right. So this is still what we'll call our vertical stretch or shrink, except we would have to call it horizontal, but we're not going to mess too much with that. But it's still our stretch or shrink factor. This guy here, K, just like it was over here, K is still our vertical stretch or shrink, or not stretch or shrink, our vertical translation. The only difference is now this is counterintuitive. Right, so if I have plus K, that means I go up. Oh, that means I go down, counterintuitive. Right, if I have minus K, that means I go up. Okay, and that's going to take some getting used to with this. And then H is still horizontal translation. Right, and it's no longer counterintuitive anymore. Right. Okay, so that does it for this video. Make sure you either pause right now or something to copy down this entire table. This entire table you've got to know, along with these side notes here, and obviously here, especially this, because we're going to have to know how to calculate P. All right, because that is how we calculate the directrix and focus of a parabola, is by knowing what P is and plugging into the formulas we see here on this table, depending on if we've got vertical or horizontal axes of symmetry. Next video will be some actual worked examples. All right, goodbye.